All right, let's get started here. 10.3, solving rational equations. It's going to be the first time in Module 10 you have an equal sign. And what does an equal sign mean? It means things just got so much easier. Because remember, when we have an equal sign, we can multiply anything that we want. Let's multiply and just get rid of the fractions. So if you look at this example 1 has a least common denominator of 6. I'm about to draw grouping symbols, multiply both sides by the LCD, and just get rid of the fraction bar. So I'm going to multiply each piece. 6 times a negative third is going to be a negative 2. Now remember, you have to do the other side of the equal sign, so that is going to be 6x. And that's just a basic, like, they might do that in elementary school. So look at this little baby equation we just solved. So easy. All right, let's look at example 2. LCD. You should know the LCD as soon as you see that. The LCD is just a 9. So we're going to multiply both sides by 9. 9n equals a 1. And then remember, 9 times 2 is 18. 18 divided by 3 is 6. Little baby equation. So easy. So easy. All right, let's look at example 3. By the way, example 3 is also on page 11 in your packet. So the process is the same. There's more numbers, there's more letters, but we're still getting rid of the fraction bar. So remember, for numbers, you want the LCM, and that's just going to be a 10 there, but you want the highest exponent for any variable. Those rules still apply, just like if you were adding or subtracting. The LCM for this is an m, obviously, for both of those m's in the denominator, and the lowest common multiple is going to be a 10. So let me write a 10 out to the side. That doesn't look proper, but it's just our work, so it's fine. So look, we are going to multiply 10m by the first piece here, the whole entire piece. So remember, it is not just like a snippet. You want the whole entire thing there. Okay, so 10m divided by 5m is just 2. So that's going to be 2 times 3m plus 2. So that's usually how it works. Let me recopy the plus sign. Let's take a look at the middle piece of the fraction. So 2m minus 1 over 2m. And then we're going to multiply that by 10m. Remember, that's like over 1. The 10m and the 2m cancel out to just a 5. So that 5 is going to be multiplied by 2m minus 1. So don't forget to always do the other side of the fraction bars or the equal sign. Don't forget the 4. That's just 40m. We're going to distribute and just solve. So look at how I magically showed all of my work like that so fast. Pause it if you need to. Make sure that you get the same thing I got, because you need to check to make sure you did it right, but I need to check to make sure I did it right too. That's what I got for M. All right, so here we go. Next problem is going to be this one. So let's go ahead and take a look at this. We got 3 pieces in our denominator, which means we're going to be multiplying by 3 binomials. Multiply by all of them. I'm going to write diagonal to show a little more room. And then the one that's already in the denominator, that's just going to cancel out. So this first piece, that x minus 1, that goes away. So I'm really just multiplying the 6 by the x minus 2 and the x plus 1. I'm going to recopy the equal sign. Same with the 4. The 4 has x minus 2. So it's just going to be 4 times x minus 1 and then x plus 1. Yep, those are going to cancel, y'all. All right, last piece is a 2. The 2 has an x plus 1. Those would cancel. So we're going to multiply the 2 by x minus 1 and x minus 2. So listen, when it comes to this, guys, the fastest way is to FOIL those binomials and get yourself a trinomial, then distribute the number on the outside. I'm just going to recopy the 6. I'm just going to go ahead and FOIL out, recopy the 4, FOIL out. That's a difference of squares. Recopy the 2, FOIL out. Now distribute. Don't forget to distribute it to everything inside the parentheses. Okay, look. This is kind of a unique scenario, and I'm going to tell you a bunch of stuff that I'm not writing down. So if you have your volume on and your earbuds in, good for you, because you're getting important information. Check it out. right now that's a 4x squared and a 2x squared over there on the right side. And I have the same exact thing on the left side. I have a 6x squared over here on the left side. Those are going to go away. My quadratic terms are going to completely cancel out. Look at my linear terms. My linear terms, just the single x, they're both the same thing on each side of the equal sign. Those are going to cancel out. Gone. So I'm left with some numbers here. I've got negative 12, and then on the right side, I've got a negative 4 and a positive 4, so of course that's 0. Listen, you should remember this. If like everything cancels out and you end up with a false number sentence, then you need to remember that the answer to this is going to be no solution. No solution, false number sentence. On the flip side of that, y'all, if it was negative 12 equals negative 12 or 0 equals 0 or whatever, an absolute true number sentence, it would have been all real numbers except the restrictions. So if that was a true number sentence, I would write all real numbers except positive 1, positive 2, and then negative 1. Keep that in mind. All right. Okay, so now what we're going to do is we're going to talk about what kind of happened when we had absolute value. Remember when you solved absolute value equations, you couldn't have numbers that equaled negative because absolute value didn't equal negative. Same kind of process is going on here. You are going to have to still check for restrictions. I'm not making you state restrictions, but you have to check for restrictions because some answers are going to be extraneous. And remember, an extraneous answer for this would just be you got an answer that's also a restriction. Cannot have those answers. All right. So this is the last problem. We're going all the way back to 7th grade for some of us. Remember proportions. Proportions are coming back. Proportions are 2 equal ratios, by the way, and it's the only time in math that we get to crisscross multiply. And some of it called the butterfly method. So I love that. I had to draw a butterfly for that. And just remember, you know, we multiply diagonally and we set them equal to each other. So here I'm going to do x minus 1 times x plus 1. You should not have to show work for that. You should know that that's just a difference of 2 squares. So I'm just going to write down x squared minus 2, or x minus 1, recopy my equal sign, and then of course 4 times 12 is 48. Let's solve, move the 1 over, it's a 49. We are going to get ourselves nice clean whole numbers. You got 2 answers here. Remember, when you draw square root, you draw a plus minus. Also remember from absolute value, this symbolism to show pure good answers is going to come back. And I'm talking about the braces. So you're going to also see our answers written in this form too. All right, so how do you get credit for sitting through all of these notes and listening to me talk? What you're going to do is, if you could please just do these problems right here, 1, 5, and 10 on page 24. And can you please tell me what is so wrong with this screen right now? Like, it's embarrassing. But again, if you had your earbuds on, you should hear me. If you tell me what is wrong with my notes right now and just drop it in the text box, I will appreciate that. All right, guys, that's it. Thank you for sitting through all those notes. We are so done.